Devang Sutaria has gathered considerable experience in dealing with diverse structural engineering challenges and has handled structural designs not only in RCC but in structural steel and composite structures depending upon the project requirements. He thinks it is very important to have strong aesthetic sense and an ability to understand client and architects' expectations in order to offer them innovative, constructible, and efficient structural designs. He has worked on varied types of projects ranging from large residential layouts, commercial buildings, hotels, resorts, institutional projects, convention centers, malls, auditoriums, industrial structures, as well as some infrastructure projects. Devang Sutaria strongly believes in a process-driven design and believes that an effective design dialogue, right from the inception stage of any project, helps build better projects. This is particularly more significant in the context of large-scale projects where multiple experts contributing to various disciplines of designs are involved in the design of the project. Today, he is going to interact with us on the subject of understanding loadings and forces on building structures from structural engineer's perspective. Thank you.
Thank you, Shruti. Devang sir, all yours.
Okay. Thank you, Shruti, for the nice introduction. Good afternoon, everyone. So I'll start now. Let's start. So the topic is understanding loading and forces on building structures, a structural engineer's perspective. So what I'm going to try and do is I'm going to try and connect you, with my experience of having interacted with so many architects over the years, and typically what kind of interaction takes place, and how do we come about, how do we gather the information in terms of the loadings that we have to account for and design the structure, the process, and then what are the loads on the structure that we account for, and what is that process. So I'll take you through the process, and then at the end I'll show you all the loadings. So I'll begin now with the slides. So where do we start? What is the process? What is the popular approach on a project? Okay, so typically a client comes to an architectural consultant. The architectural design starts with an interaction with the licensing authority or licensing architect. So there is a design architect, a licensing architect, there is a structural engineer, there are services and MEP consultants, and landscape and traffic and other consultants like facade consultants and the green building consultants and vertical transportation consultants and everyone. But what happens in this popular approach is that there is a minimal interconnectedness between different consultants. Architect design plans are sent, sometimes vary for different consultants, and there can be some lag in the process, the information processing. This is more of a linear process and not a parallel and completely interactive process between all the consultants. What happens? So due to this, there is a probability the result could be, there could be confusions, there could be rework, there could be a lot of back and forth, but the boat is not going anywhere, and it may actually get into some kind of aggression in between. You might end up having late working hours. So how about being in control of everything like these famous people? Now, who are these famous people that, as architects, probably you've gone to the history. Okay, so let's see. Leonardo da Vinci. He was a thinker, he was a philosopher, architect, sculptor, painter, and engineer. So he was in control of his projects, Bernini, Renaissance period, and he was also an architect, sculptor, painter, and planner. So you see all these beautiful structures they could do. Similarly, in modern times, a person who's in control, is like somebody like Kalachava. So if you look at these buildings and these concepts of Kalachava, uh, the turning torso is based on Kalachava's sculpture called twisting torso. It's an inspiration from the human body in a twisting motion. So Kalachava's works are generally inspired by things in nature and understanding of how they respond to the natural forces during their lifetime. So, beautifully, you can connect these trees, inspiration from the tree, and you can see this and this. You can connect with these tree columns over here, and so on. So, similarly, again, these tree is a Valencia Science Center in Spain by Calatrava. Look at this Kalatua's work and the concept sketches. Very strong concept. So he's an architect and he's a structural engineer. So he is able to stay in control of what he wants to produce. And but what is common? So these designers have better understanding of different disciplines of design. That brings us to the subject of the projects that are happening around us or how the city of Mumbai has transformed. If you look at the top left image, we see the high rises, the tall buildings, and the Parel and Worli area in the background. The top center is Psyche Hospital and the other buildings, and you could see different, height structures. So there are high rises, there are low rises, everything. Top right, you see Hiranandan. You see bottom center, you see ITC Ground Central. Bottom left, you see the hospital for Kokilaben Ambani Hospital. Bottom right, you see Westin at Goregaon along the Western Express Highway. So these are all, and you can see different facades for these buildings. So these projects over the years have become large, and the complexities on these projects have, increased manifolds because of the scale of the projects. So for many projects, the scale and nature of the project these days are fairly large and complex. Various design consultants and other consultants have to be involved due to their expertise in respective fields. It is imperative, hence, to have a good teamwork to successfully deliver a project. Due to involvement of multiple design agencies, licensing agencies, clients, and the architect being in the center of everything, it's important to have a collaborative and integrated approach to design. So, because now with this level of complexity, the expertise required, you can understand, is very different. And now, how Calatrava is achieving the the delivery of his project, it's not that easy. For us to do, you need somebody who extraordinarily, gifted like Calatrava to do everything by himself in these modern times. So, what is integrated approach to design? So you have client and architect in the center. You have other consultants, and as you can see, structural engineer, services, MEP consultants, landscape, traffic approvals. A couple of more circles actually should get added over here. The facade consultants, the vertical transportation consultants, the green building consultants, and yeah, that's where you will be able to solve the design jigsaw puzzle. So if everybody works together and tries to solve problems in a mutual way with an interactive and integrated approach to design, the solution could be brought about at a much faster pace because time is of essence. Every client wants it now. Nobody can afford delays. Your project has to be delivered with optimum performance parameters and optimum design parameters. Cost is of essence, the area consumption is of essence, and there are so many things which are involved. Now, so to understand interdisciplinary requirements, and we need to respond accordingly. So that's where, as a structural engineer, what I look forward to. So how do we as structural engineers, we gather the information and how do we process, how do we assess the information at the beginning of a project when we when we get onto a project. So that is what I'm going to talk about. And then from there on, how we interpret the data that is being shared by different agencies and how we extract the loading data out of that. And then what are the loadings? That's how I'm going to connect the dots today for you. So, the study of all preliminary architectural drawings and understanding architectural design brief and understand the following. That is how it starts, the process starts. So we study the master plan, we understand individual building or building's position on the master plan, we understand building typology based on the expected occupancy, whether it is residential, commercial, hotel, retail, mixed use, IT park, hospitals, etc. Because the livelihood and the planning of all these kind of buildings, they vary. The internal loading, depending on what material goes into building of this structure, they vary. Because everything has got specific requirements, and you may understand. We understand the relationship of each building with adjacent building or buildings, within the premises, and to understand common and or connected area like basements, multi-level car park provisions, podiums, etc. Sometimes the blocks are connected. These days the projects are quite large and there are multiple blocks in a project with common connected areas. We understand individual building floor layouts from top to bottom, including common areas. We study the entry and exit points of common area and individual building blocks. Study the circulation areas for movement of people like staircase, corridors, vertical transportation paths. Sometimes they are staggered, the vertical transportation paths, and or they are level specific, which Mr. Matthews must have explained to you. And then the vehicular movement, cars, heavy vehicles, commercial vehicles, fire tank, because everything has got some implication on the loading that we account for in the structure. We study the spatial provision for car lifts, car parking system. These days you get, different car parking systems. The car parking towers are sometimes included in the redevelopment project these days. Puzzle parking is done on large-scale projects to accommodate more number of cars and to improve the parking efficiency on the project. We study the areas earmarked for services, that is MEP, mechanical, electrical, and plumbing. Underground water tanks, overhead water tanks, STPs, pump rooms, and the equipment, what equipment would come into that. Similarly, where the DG room would be. So, electrical room, building management system, a lift machine room, server room. If there is an IT tower, a high-rise IT tower, within an IT park, then there are server rooms, battery rooms, and battery racks. Whichever server rooms and battery racks are quite heavily loaded. High-speed diesel tank yards, which supplies diesel to DG. Chiller plant location, cooling tower locations, air-cooled chiller locations, air handling units, AHUs. Study landscaping zones and understand broad landscaping requirements. Now, what I'm talking here is this is all initial grasping on the project and gathering information. We understand the site boundaries. What is the road access and neighborhood building heights? everything is critical. If there is a neighborhood building, you will see in the forthcoming slide that there can be surcharges. The foundation of the neighborhood building could be at a higher level than the if we have got a deeper basement, then there could be surcharge on the sides if you excavate the site. So you have to be very careful. You can't endanger an existing building. Understand floor to floor heights from lowest building level, that is basement to roof level or foundation to roof level, and provisions of above terrace elements like elevational features, spires, overhead tanks, equipment provision zones, etc. Now if you look at the so we also need to understand the cross section through the building. So understanding the cross section of the building. If you look at the left image, it shows from top to bottom. Let's go. Sky atrium you can see here. Sky restaurant and bar. Lunch room. So that's again in MEP area. Owner's apartment. Then standard club and suites. So this is for the hotel. Spa. Lunch room again intermittently. Standard hotel rooms. Specialty restaurant. Plant floor. Office at lower levels. And then lobby areas and whatnot. You can see the landscape area over here. You can see the driveway here. Then there are basement floors. This is the main road, access to this canopy, and this is the facade. You can see the facade over here, and you can see the elevational feature going up over here. Parikshit, am I very clearly audible? Hello?
Yes, yes, yes.
Okay. Is the pace all right, or am I going too fast? Hello? Is the pace all right?
Yeah, yeah, perfectly all right.
Okay. And if you look at this cross section on the right, you can see the basement. You can see the office. Now here you can see the elevators. These are office parking shuttle elevators. You can see office low-rise elevators up to this level, the level 13, and office high-rise elevators. So this is what I was talking about, the vertical transport in a staggered manner. So the loading would differ depending on up to what level the elevators are going. Hotel passenger elevators here for the other block. There is an atrium here. You see the escalator over here, staircases, the ballrooms, occupancy is different, health club, lab pool, meeting rooms, hotel lobby and registration, ground floor office lobby. So this is an office tower block and this is a hotel tower block. So you can imagine the difference in the loading over here. And so we interpret from the cross section what is the floor to floor height and how the facade is there, what is the elevation treatment along the edges of the building. All this data that we collect, we understand, and we anticipate what needs to be accounted for in terms of the loading once we study the floor plans and the sections. So that brings us to this slide. So you can see to the left a nice simple line diagram indicating basements with cars over the car park area. You can see escalators, you can see the landscape in between the two buildings, and you can see the tower blocks. So elevational loads, what we draw out of all this information that we are looking at as structural engineers is to understand elevational loads, like we look at whether there is a provision for flower beds, chadjas or weather protection, canopies, what is the cantilever of the canopy, how we would support that, boxing treatment in elevation, cornices. Cornices are relatively out of fashion, but they could be there. Pardis, curtain wall glazing, dry cladding, granite, etc. Spatial facade treatments, you can fins, spires. So this would go under elevational load. area specific loads. Podium slab, etc. Landscape fill. You can see this is a podium and there would be a landscape fill over here. Flexibility in landscape design. You may have water bodies, you may not have water bodies. Initially, sometimes the landscape consultant is not able to commit to what depth of soil fill he will require. So we need to understand the parameters in terms of what is the flexibility anticipated. Because everything affects the loading increases and if the span remains same with less loading, you can understand the beam depths would be less, the slab thicknesses would be less. With more loads, the beam depth would go up, the slab thickness would go up. Fire tender mode. Fire tender has got, it depends. Now in Bombay, the municipality sometimes says you have to account for a 70-ton fire tender. So the number of wheels and the loading per axle is quite high for a 70-ton fire tender. Because of the high rises now, the capacity required for fire tender has also gone up. And sometimes you have to actually take the fire tender up to the podium because from there you can actually firefight. And the fire tender goes along the ramp all the way to you have to make that provision. So the ramp it has to be designed for the fire tender movement. Then truckload movement, light motor vehicle movement, which is normal car parking system loads. So these are all area specific loads. Services loads, air handling units, chillers, cooling towers, lift machine room, internal ductable units, external ductable units. This internal ductable units would come, as a fault, services load on the slabs, piping, whether chilled water pipe, hot water pipe, air conditioning ducts, fire hydrants, sprinklers, overhead water tank. So all these would be the services load that we try and gather out of the information that we collect while interacting with the architects and the other consultants. Now, if we look at the typical cross section here of a building with a basement, there is a water tank over here. So this is the retaining wall. You can see the ground level over here, and there is a raft slab over here. So this is a typical section to the basement. You can see, on the retaining wall, lateral earth pressure plus hydrostatic pressure would act from the side. The raft slab will have to be designed for hydrostatic uplift pressure. So what are these loads on the substructure? Earth pressure, hydrostatic pressure, surcharge to be accounted on the retaining wall. Imagine a fire tender moving right over here at the entrance to the ramp, on the external road, and the fire tender is moving a little closer to the building. The load through the soil would put a surcharge on this retaining wall. And for deep basements, you have to do enabling works to excavate. So enabling works are shore piles are kind of enabling works. Now you can see in this picture to the right bottom that the excavation is in progress. You can see these people down on the excavated ground. You can see the retention piles. There is a capping beam on top on the plot boundary, and then you can see a building next door. Now this is a low-rise building, as you can see. This building might be, this is a terrace level of this building. So might be just ground plus 2, ground plus 3 structure. And the foundation of this building would not be as deep as the excavation which is carried out on this side. But at what distance that foundation is from the plot boundary here would generate some, so that foundation of the adjacent plot to the building in the adjacent plot would generate a surcharge on the enabling works, that is these retention piles. And if these piles give away, there could be a danger to the existing building and the people living in that building. And hence, designing of shore piles is also critical as part of the enabling work. It is not part of the main building construction, but this is one of the most critical aspects. If anything goes wrong here, your project would be stalled. And so that's why this information to gather at the Beginning is also extremely critical in the planning of the project. Now, let's try and understand the loads. So, load transfer path to a structure, gravity loads, the loads go through the slab. From the slab, they get onto the beam. From beam, they get onto the column, which you all know. And from column, they flow down into the footing. And the load has to be transferred safely to the ground below. So this is just the load transfer part, understanding of the load transfer part. Dead loads and live loads. So what are dead loads and what are live loads? So the flow finish is a dead. A wall, a wall will get into dead loads. If you have toilets and sunk in the toilets, you would need waterproofing treatment. I'll show you in the forthcoming slide where you need waterproofing treatment. So the waterproofing treatment, you may need 6 inches thick waterproofing, you may need 8 inches thick or 12-inch thick waterproofing. Hello? Yeah, somebody was saying something. Hello, Parikshit? Is there a problem? Hello?
No.
Hello? Is there a problem? Shall I continue?
Yes, please continue, sir. I think that there was somebody who had gotten unmuted by mistake.
Not a problem.
Sorry.
Yeah. Sure. Wall loads are part of dead loads. The self-weight of the structure, like the self-weight of the slab, beams, column, is part of the dead load as well. And imposed loads are live loads, which are like human, furniture. You saw in the previous slides, the car loads are live loads. So the fire tender loads are live loads. Fixed equipments would get into the dead loads. You can heavy equipments would get into the dead loads or non-reducible dead loads kind of a thing. Now here you can see a typical flow plan for a high-rise structure, and this is a residential building, and you can see the beams and slab marks and the shear walls, the lift core, and then different sections which have been cut across. And the hatch portion, the light gray hatched portion, these are the toilet areas. These are the service slabs in the ducts. These are dry balcony areas. That's a nani track over here for the kitchen, and the plan is practically mirrored over here. And you can see these sections. Now you can see, if I show you here, it's a sunk. In the sunk, we have shown a 250 thick, 250 deep sunk where waterproofing would come as a waterproofing treatment. So in this project, the sunk is defined as a 250 deep sunk in which the waterproofing treatment is expected. Now here you can also see the slab at the bottom level. So if there is going to be a fill here, and that is loading of that fill needs to be accounted. Now there is a weather projection over here, and this is the Sajja projection. So everything amounts to that loading. If there is going to be some sort of a boxing over here in the elevation, the boxing loading would be modeled over the Sajja or accounted over the Sajja, and then it will get transferred to the structural system. Now for the same building, this is how it gets into the 3D model. I'm just showing you a typical flow where you can see the uniform load, that is in gravity load, that is the live load. So 2 kilonewton per meter square is the live load here. In the passages it is 3, in the staircase it is 3, but in the residential zone it is 2 kilonewton per meter square as per the code provision. Now this is flow finish. So here the flow finish accounted is 1.5 kilonewton per meter square, so which is 150 kg per meter square, which is roughly about 65 to 75 millimeter thick flooring. So the flooring thickness or the type of flooring that also you are going to use is critical to the structural engineer to understand what loading is expected. Sometimes in hospitals or in IT buildings, you have false flooring, and then in that case we need to account for false flooring load. Sometimes they don't finish it. It's only on top of RCC slab. They do false flooring directly, and then they run the services between the RCC top of the RCC slab and the false flooring for ease of execution and operation and maintenance. Now, wall loads. So, if as you can see here, bottom right image, it shows you the line load on the beams, and these are the wall loads for the floor. So this is a part, a 3D image of the particular floor, and not a complete floor. Now, so how do we understand or interpret the wall load? So we need to know the material of wall, brick walls, AAC block walls, partition walls, solid block walls, etc. So hotels, hospitals, some high-rise buildings or tall buildings might have lightweight partition walls. AAC blocks these days have become very popular because one of the reasons for the same is a mandate by the government also in terms of the green buildings and to consume fly ash produced in the cement factories, and so AAC blocks, and they also help reduce the dead weight on the structure. Reduction in dead weight also helps us in controlling the overall seismic weight of the building and optimize the design of the structure in seismic loads or combination loads. So these are different loadings and how they get accounted for and how we interpret what data we gather from the architectural drawings and other drawings. So, yeah, just a minute. Excuse me. There is some problem here. Just a minute. Yeah. Now, with that loading, what happens when we analyze the building in 3D is we get the bending moment diagram. So this is in plan. The bending moment diagram, you may understand the bending moment diagram for
Sir,
simply put it being, yeah.
you are not in presentation mode, sir. I think this is in file mode.
I am aware, but it's not taking that
Acha,
because
acha,
I
okay,
put it on the
okay,
slide. It is
acha,
escaping.
okay,
It
no
is
issue.
escaping there in the
Okay,
presentation. So I don't know why the next slide is not being picked up. That's
okay,
why
okay,
I've gone to
no issues, no.
the file. Is it visible here,
Yes, yes.
or you want me to zoom in?
No, this is visible.
Visible. Okay. So as you can see, probably over here, you can see the assembly supported beam bending moment diagram. You can see a continuous beam bending moment diagram. And you can see a fixed beam bending moment diagram. And this is this side. So this is the bending moment diagram under the deadwood liability case. And this is the shear force diagram, which you have been doing as a free body diagram for individual beams you have been analyzing in college, which you've done probably in the second year. Now, this brings to the next kind of the other kind of loads, which are seismic loads, let's say. So seismic loads are, due to the ground shaking, the seismic load get generated, and the buildings undergo dynamic motion during an earthquake. There are inertial forces which gets generated as a part of building response to the dynamic motion of the earth or ground beneath. Building is subjected to inertial forces that act in opposite direction to the acceleration of the earthquake excitation. And these inertia forces are called seismic loads, which are usually dealt by assuming forces external to the building. So you apply seismic loads on the building and study the behavior of the building under the seismic loading. So what happens as a part of seismic behavior? What are the undesirable modes of failure? So overturning. So building should not overturn and fall. Horizontal shear of the building should not take place. And this is the shear failure of the building. Building should not diagonally also shear off. What is the desirable mode of failure or response of the building? So, a flexural tension failure. So, basically, the building goes in bending. There is tension on one face, there is compression on the other face, and you can take care of the tension by designing the elements in the frame of the building or shear walls of the building to take care of the tensile forces which come on the tensile stresses which come on the element. What happens due to the lateral force that comes on the building. So the earthquake induced horizontal forces at different floor levels. Because of the total earthquake force, the base shear is maximum. So the horizontal force at the base is maximum, and it reduces as you go up along the height of the building. And you can see how the 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 elements resist the earthquake forces, and how the earthquake motion generates the inertia forces in the structure over here. Seismic zoning map of India. So you can see the different zones, seismic zones in India. So as I'll just zoom in a bit. The blue is the zone 2, which is the minimum zone or minimum impact zone in case of earthquake, or minimum critical, I mean, it's less critical zone. Zone 3 is where we fall, Mumbai falls, that is zone 3, Mumbai, Ahmedabad, uh, Cochin, Trivandrum, and the west coast of India largely falls in zone 3 and zone 4. So part of the portion like Konkan belt is falling in the zone 4. Part of Gujarat falls in zone 4. The Bhuj zone where we had the 2001 earthquake, it falls in zone 5, which is the highest seismic zone in India. Some part of the Himalayan range falls in that zone, and the east of India, the extreme east of India, falls in zone 5. And this is just above Patna, you can see, adjacent to Nepal. We all know that the recent earthquake in Nepal was quite, it had devastating effects in Nepal. So this is a seismic zonic map of India, and the earthquake forces are worked out in line with the IS 1893 2016, which is the latest code for earthquake resistant design of buildings. I will take you to a typical design basis report and how this information that we gather in terms of the building, uh, we put in the DBR, and then how we use that DBR. I will show you that later on once we finish these slides. Uh, Then it brings us to the wind load on the structure. So imagine this as a typical vertical tower block. So, once the wind comes, wind pressure, it is assumed for simplicity of analysis, you assume that the wind comes from one direction and then how it impacts the building as a whole and the response of the building as a whole under wind load. That is how why we analyze the for the wind loading. And so once you apply this wind pressure, you get different pressure coefficients on different surfaces of the building. There is internal pressure, there is external pressure, and the loads are converted as point loads at column nodes. And the resultant forces, they act at the CG of each floor diaphragm, which is the building floor center of gravity of the building. And so I'll show you this, the effects of the wind forces, how the wind force envelope, this is in elevation, it takes place, and how in plan it affects the, so wind pressure, if wind is coming from this side, the maximum is on this side, this is the windward side, this is the leeward side, these are the two sides, and the forces on the sides here, because the wind would come and there would be aerodynamic flow of the wind around the building, and the facade elements might undergo larger, they may undergo larger pressures along the edges, or you can shape the building, in a way to deal with the wind loading. And when you deal with high rises, you also have to look into the shape factor of the building that is given in as part of the code provision. So how you deal with so how the pressures are worked out depending on the factors for the pressures are worked out depending on the shape factor and how the wind flows around it. There is a specific science to it. We will not get into the details of that. I'm just broadly talking to you in terms of the broad understanding of the wind load. So effect of wind load on high-rise structures. If you look at this as a cantilever beam coming above the building, as a cantilever beam coming above the ground, there is a load from the left side. Now it causes shear, or something similar to the earthquake. Because the total wind, the building, the building as a beam resists the total shear at the ground level or the foundation level, and it will cause a bending moment in the building. So the moments at the base level or the foundation level will be highest, and because of the fixity in the ground, if it is not fixed, the building will topple. And since it is fixed, held in position, well founded, well grounded, so now as part of its resistance, it undergoes part deflection. Now these deflections have to be within certain limits. uh, Generally, they are kept under wind load. They are kept, to the tune of height by 500. That is the limit for the drift in wind. So if you keep the deflections on detail in terms of the behavior of the buildings, you will be informed about in forthcoming lecture by Sangeeta Datte. But I'll just touch upon the subject and leave it there for her to uh, look in, give you more information about that. Now, this broadly closes the most of the generic loading which comes on the building. Now, there could be construction stage loading, and these days you see a lot of buildings in the parade area or a lot of high rises where you can see only the service floor going up. There are trains mounted on top, and the surrounding floor plate is climbing up little behind the service floor. And so there are jump forms being used, there are slip forms being used. So there is a construction stage loading also, which we account for in the as part of the construction strategy that is decided on the project. and we have to account for those loadings also. So even the discussion on how the building construction would take place. So that brings you to the subject of the construction technique for the building, and the overall planning or the timelines of the building. So there are multiple aspects which go in the planning of the project and construction of the project. I've left this slide blank over here because I want to show you now, take you to the design basis, report, and I'll just show you that quickly. So I'll show you a typical design basis report over here, and this is a structural design basis report for a typical residential building at Mumbai. Table of contents. So forward, preamble, project description, design brief, design standard, list of codes, design parameters, proposed approach to structural analysis, load combinations, design of structural elements, procedure adopted for design, stability of structures, geotechnical data, soil parameters, foundation systems, foundations and recommendations, precaution against presence of chemicals, other data and guideline decisions. I have skipped a couple of initial paras.
Sir, are you showing some slides?
Is it visible or not visible?
No. So your blank slide is visible currently.
Oh, it's a Word file. Just a minute. How do I share it? I'll share it. Just a moment. I'm sorry. Good that you pointed out.
Yeah, sure. No issue.
It's showing blank right now.
Yeah, I think you'll have to come out from this presentation and you'll have to again share the Word document.
Is it visible?
No, now you're not sharing anything. So now you share the Word document.
Yeah. Just a moment. I give it 2 minutes.
Yeah, sure.
Screen sharing is not there right now. So I've shared the screen.
Not shared, I guess.
Yeah, it's not there. It's coming.
Yeah,
it's not.
yeah. Now it's appeared.
There?
Yeah.
Sorry.
Now
So
we can see this.
this is a structural design basis report for a residential building at Mumbai. So these are the different aspects which we cover within in the as part of the DBR. So
It's not
project
moving.
description, design brief. Sorry.
It's not moving yet. I guess just a title which has been shown here.
We are still seeing the. What are you reading there?
Vinith, it is moving for me actually. There could be some
Now,
internet issue.
now it's moving.
It's moving. Yeah.
Can you see the table of contents?
Yes.
Okay. So forward preamble, project description, design brief, design standards, list of codes, design parameters, proposed approach to structural analysis, load combination, design of structural elements, procedure adopted for design, stability of structures, geotech data, soil parameters, and foundation systems, foundation recommendations, precaution against presence of chemicals, other data, and guideline decisions. There is a broad outline of how we go about the design. So So what is important for everyone to understand is that we go to the second paragraph. The parameters adopted in this report are going to be the basis of the structural design calculations. Hence, it is expected that the planning and design team members, architects, services consultants, landscape consultant, vertical transport consultant, peer review consultant, and client's project management team give their feedback and approval to the parameters, suggestions, recommendations mentioned in this design basis report. So, what the report aims to do is it aims to achieve a structural and functional integrity, a desirable structural performance, and the characteristics service design loads, resistance to loads due to natural phenomena, that is wind, earthquakes, and thermal loads, structural durability and maintainability, structural safety, performance during fire and fire safety measures, compatible compatibility with all relevant IS codes of practice. This is the aim of the design, and so the project description is given how many floors for the buildings and what are the from top to bottom the description of the building is covered under this, and at the end we are saying here that the proposed structure is expected to be designed essentially as RCC structure with shear walls, columns, and conventional slabs. The columns and shear walls will be connected with each other with conventional beams and slab diaphragms for effective transfer and distribution of lateral forces across the floor plate. The floor-to-floor height has been understood, and different parameters, total building height has been understood. What are the different elements, as we discussed earlier, have been mentioned in the above para. The building will be designed for the number of floors as shown in the architectural plans issued to us at this stage. The building shall not be designed for any additional floors over and above the number of floors shown in the architectural drawings as issued to us unless specifically instructed to us. So it is important to understand that the flexibility in planning, if at all you are planning in terms of later date addition of floors, it needs to be conveyed to the structural engineer at this stage before he begins his planning structural framework. Because if you decide, if in a high rise, if you have a 50-story structure and tomorrow you say, I want to make it a 60-story structure, adding 10 floors would, completely change the design parameters. It will change the wind load, it will change the earthquake load, it will change the dead load, live load. And the foundations may not suffice, the shear wall sizes or the column sizes may not suffice. And hence, understanding what is required, as a long-term planning on the project needs to be closed out at the design basis report stage so that the structural engineer is, takes into account everything that has been anticipated. And that is why the design basis report becomes very critical and everybody needs to focus on it and give their comments right at that stage so that nothing is missed out as part of the loading. Design brief. Uh, the building is predominantly intended to be a RCC frame structure. The main lift core appears not to be oriented along the orthogonal horizontal direction. Hence, the structure shall be designed for the effect due to full design earthquake load in one direction plus 30% of the design earthquake load in the other direction. Now, this is as per the earthquake code provision. The structural scheme of individual floors. The institute floors are, sorry, this is not institute, this is residential building. So the residential floors are planned as conventional slab and beam arrangement in almost all the areas. The sunken areas and the larger opening in slab will be framed by RCC beams. Performance criteria. So maximum deflection, for comfort of people living inside and to ensure that there is no damage to the building or elements of the building. The performance criteria in terms of the deflection of the beams, the slabs, and the building as a whole. The individual floor elements as well as the building as a whole are defined here. More details, I think, would be covered by Sangeeta Date in her lecture as part of the building performance. The following combination of structural members will be used to form the framework of the building foundation. The concrete grade is planned as so and so. Grade of concrete is mentioned. It may be increased if need arises at detailed design stage with reinforcing steel of if you find a D grade. Suitable foundation system will be adopted and will be designed as required for the structure based on the geotechnical inputs received. Basement rough slab and retaining walls. So the grade is mentioned floors. All floor slabs in the building area from basement and above are likely to be considered as RCC slabs and beam arrangement with M35 grade and Fe500D grade reinforcing steel. These may be increased depending upon the final loading and design requirement. Principally, the slabs would be considered in participating in frame action in resisting lateral loads as part of the floor diaphragm. And slabs will be designed only for gravity loads and beams. So RCC beams with so-and-so grade or higher will be used, which will create a frame connecting all columns and walls within the floor plate of the building. And similarly, columns, RCC columns and shear walls would be connected with each other using the beams as part of the framing. And shear wall would be would cater to gravity as well as lateral loads. Column, which are part of the main framing, will also cater to the lateral loads. Core walls will act in conjunction with peripheral columns, RCC shear walls to resist lateral forces along with serving as lift shafts. So a general arrangement layout of all floors indicating columns, shear walls, beams, and slab arrangement will be developed and will be coordinated with the architects and will form part of the concept design. The final column layout and general arrangement plans of the floor of the building will be submitted in our preliminary design package for further coordination approval of the peer review consultant. This is part of the process. And we will be submitting general arrangement plans for perusal of the design team members. Now, all consultants who are involved need to go through the general arrangement, structural general arrangement plan, and who are expected to note the salient features of the structural system and examine the compatibility with various requirements of the architecture and other engineering disciplines. That is where the integration becomes very critical. If somebody says, if the floor to floor height normally are critical and the services person might need a sleeve through the beams or some opening to the beams, and we have got a limited beam depth, so the forces on the beam should allow us to introduce that opening which the other consultant needs. That is where the interaction is required. That is where the compatibility has to be brought in, and the jigsaw puzzle has to be solved at the design stage itself, the preliminary design stage itself. The coordination among various design team members will be part of the design development process, and we as structural engineers will be part of the process. In Mumbai, it falls in 189. So, as per the earthquake code, the Bombay falls under seismic zone 3, as we saw in the seismic zoning map. There are multiple parameters in 1893, which are quite, nuts. So, all parameters need to be complied with. Now, design standards list of codes. So here you can now see, the focus will move from the codes to the loading, and so design loads other than earthquake loads. So IS 875 Part 1 deals with the dead loads, that is unit weight of building material and stored material. It gives you the unit weight of individual materials. So based on which you can actually calculate, like the density of block work is given, the density of brickwork is given, the density of soil is given. and you can, based on which you can actually calculate the loading of the same. IS 875 Part 2, it talks about imposed load, which is the live load. 875 Part 3 talks about wind load. Earthquake load, gets covered under the design for earthquake resistance. So the earthquake load gets covered under IS 1898-2016, criteria for earthquake resistant design of structures. There is detailing code for earthquake. All buildings in zone 3 and above need to be detailed as per the ductile detailing parameters given in IS 13920. And once you come in practice, you will realize, or you will understand more of this in detail, and we will talk about this more in detail or cover this in the subsequent lecture, which is on the type of framings for the high-rise buildings. Design of concrete elements would be done as per the following codes. Structural steel would be done as per the following codes. I hope the screen is not scrolling too fast for people.
No, now
Can
it's
someone
fine.
confirm?
Yeah, now it's fine. Hello.
So the design parameters are jotted down, like material for construction, concrete, like what grades of concrete we are going to use, cement, aggregate, admixture, additives, water, reinforcement, the grade of reinforcement, structural steel, the grade of steel that we intend to use. Now this brings us to the loading parameters. So self-weight. So self-weight of the structural members will be considered on the basis of the following properties. Density of reinforced concrete, 25 kilonewton per cubic meter. So depending on the element size and the volume, and if you apply this density, the loading can be worked out. Plain concrete, PCC would fall under plain concrete. So that is 24 kilonewton per cubic meter. Density of steel, reinforcement steel weighs at 78.5 kilonewton per cubic meter. Flow finish and plaster at 20 kilonewton per cubic meter. And so depending on the thickness of the flow finish, at 20, you account for the floor loads. Density of soil, 18 kilonewton per cubic meter. This is required for working out the load on the landscape areas and are working out earth pressure on the retaining wall and all that. Dry density of rocks. If there is a rock fill somewhere which is coming as a dead weight, for example, if there is a basement and you have uplift pressure, you will have to put on dead weight on the basement roof slab to resist the uplift or part dead weight. So then, or there is a rock fill that required. Density of bricks. If you have brick walls, then the loading, the wall loading, which I showed you in one of the slides, it can be, the line load can be worked out with the with the thickness of the wall and the height of the wall on the floor. You can work out the line load using the density of the bricks or block work or lightweight or C4X. If it is C4X or AAC block, it can be 6.5, which is, as you can see, as compared to brick, this is almost one-third the weight, and hence in high rises, AAC blocks have become the norm these days. So it also caters to the green building requirements, and also the dead weight of the structure can be reduced. A reduction in gravity loads allows you to have control over the total dead weight or the gravity loads coming on the column, which allows you to reduce the size of the column and offer larger flow plate areas for usage. So imposing gravity loads on floors. So we jot this down, and we want the architects and other consultants to take note of what loads we have accounted and what kind of finishes we have understood from their drawings. If they intend to change anything, they need to tell us at this stage or the preliminary stage or the design development stage. So when we get into the final analysis and final design of the building, we don't have to coordinate a revision and we don't have to deal with delays on the project deliverables. And that is where it is very important for everyone to focus on these parameters. The following are the imposed gravity loads adopted in addition to the self-weight and flow finishes. So finishes, load component are written to the left here, terrace, level is terrace. Load component is finishes, thickness is 75, UDL 1.5 kilonewton per meter square. Services false ceiling load is 0.75 kilonewton per meter square. Filling and waterproofing. Terraces have waterproofing depending on the area of terrace and the the rainwater downtake pipes. The waterproofing treatment selected for the terrace depending on what region of the country you are in and what treatment is recommended. The thickness of filling and waterproofing can vary from 150 to 200 or more. So based on the thickness on the project, the UDL on the terrace would be considered based on the density of the material using which you are going to do the waterproofing. So if it is 150 to 200, assuming 20 kilonewton per meter square, it will be 3 to 4 kilonewton per meter square as loading, which is brickbat cobar. Density of brick is 20. So brickbat cobar typically would give you that kind of loading. Live load on terrace, 5 kilonewton per meter square, but there is a remark here to be confirmed by architects. So if the architect says, I want a 300 thick over here, the loading would change to 6, and so on and so forth. Or if he says 250, it would change to 5. A live load to be confirmed by architects and MEP. Sometimes the MEP people, MEP consultant might suggest putting up some services loading, and hence it's better sometimes to keep a provision of 5 kilonewton per meter square, so that later date you don't have a shortage in terms of the load provision. Because client might want to put up solar panels or want to mount some uh, mobile towers, holdings. So if holding is there, sometimes spatial loading has to be accounted for holding, and we need to understand also the holding position and loading tentative position and passages. In passages, the load component again finishes 75 thick, 1.5 services falls being similar, live load, 3 being a residential premise, staircases, steps. So the dead weight of the staircase, the tapas or the stairs. So 1.875 kilonewton per meter square to be modified as per actual rises and trades. Finishes again similar, live load 3 kilonewton per meter square. Lift machine room finishes 100. Thick 100 thick finishes considered because sometimes they do PCC or premix flooring because of the equipment loads which come on the heavy, the motor and all those equipments which come on the lift machine room. Live loads minimum 5, but typically they ask for 10 kilonewton per meter square, which will have to be confirmed by the lift vendor. They give in their drawings what loading you need to account for that. Partition wall. Sometimes there are partition walls if it's a larger lift machine room. So 2.5. But typically won't come. I think it's come here by mistake. Now for a 1.5 BHK and 2 BHK blocks, finishes 75 units, so the UDL is similar, services load is similar for considering false ceiling. Live load varies from 2 to 3 as per area allocation. Now sometimes if you are in the balcony would go to 3, and internal areas would have 2. Partition wall load. If there are lightweight partition walls considered, sometimes we design a larger slabs, uh, accounting some loads. In high rises these days, flat slab has become a norm between without flat slab means not just flat slab and drop panel kind of a system, but a slab without beams for larger areas like living rooms or living dining, if it's an L-shaped layout or something, many times you don't want to see the beam on the ceiling, and uh, even the kitchen or pantry, you have open kitchen, so you don't. Some people might like to have the wall. Some people may not have the wall and have open kitchen, and that partition wall which comes between the kitchen and living dining, goes in as a lightweight partition sometimes. So it can be an AAC block. It can be a part, part wall, with a laser height of about 750 to 900, depending on how the interior is being done. So then the whole slab might be designed without a beam, and in that case, this partition wall load may have to be applied on the slabs directly. Toilets, finishes, services, or false ceiling loads again. Sunk 150 to 300 we discussed earlier. So again, the sunk will have to be confirmed by the architects, and of course with the input of the MEP consultant. Live loads to kitchen, bistro, dining. Uh, for this building, we have a lower level provision for some kitchen, because part of that is a service apartment kind of a thing. And so finishes, services load, live load will vary in the kitchen area 3 to 4 kilonewton per meter square. The refuge areas, fire refuge areas, for that, because a lot of people can get onto that refuge platform, refuge area, the live load is going to 5. There won't be, typically there won't be services load, and false ceiling won't be there in the refuge area. And but if it is there, you have to account as at 0.75. Finishes would typically be same. If it has got waterproofing, then it will have to be added in the refuge area. If the refuge area platform is an external platform jutting beyond the building line, if it is inside and refuge area are typically open from the sides, in that case, uh, if a sunk is given, then you might need to even consider waterproofing area or loading on the refuge area. And we need to understand what is the depth of the or the thickness of the waterproofing. Wall loads on beams will be considered as a UDL in line with wall thicknesses, as shown in architectural drawings with relevant reduction in loading for doors and windows. The material for walls will be considered as per architectural specifications in appropriate plaster finishes. Now, if you change your specification as architects later on, and if you make it a lighter material, it is all right. If you have shown brick wall and later on, if you change it to Ciporex, it is still, we can still accommodate it. But if you show AAC block and tomorrow you say, no, now after the building is designed and construction is started, somebody comes and says, we want to change it to brick wall, it is not possible. Because as you saw earlier, the density of material is different. Also, you would do injustice even if you have designed for higher loading and you change the loading to a lower loading. You would not have optimized the design of the structure, and hence it is very important to talk to the client well in advance and decide the material for wall construction, because the even the sizing of the wall material, they differ. Bricks come in different sizes. Ciporex blocks or AAC blocks come in different sizes. The solid concrete blocks come in different sizes. So the thickness also would vary. Even if the thickness varies for the wall, the beam, typically you would like to have the beam and wall line external edges flushed, outer edges flushed, so that you don't see any beam jutting out above above the wall. If you are sitting in a room, you don't like to see those niches created by the offsets, or the offsets rather, between the wall and the beams, or partition walls and the columns. So that is where defining the material right at the beginning becomes very critical. Appropriate vehicular loads will be considered on ramps and any other slabs over which vehicle movement is expected, depending upon the type of vehicle movement expected. We discussed earlier what vehicular movement. Specific loads given by architects for landscape on slab, if any, will be adopted wherever applicable. Wind loads. So wind loads will be calculated in accordance with IS 875 Part 3. Design wind speed. There is a provision how to calculate the wind speed. Bombay wind basic wind velocity is 44 meter per second. Wind gusts might, this is the highest. In this in Bombay, this is highest, and even the current storm, which are cyclonic storm, which was there, was actually not to this extent, and this is given by the code based on 50 years average of 50 years, past 50 years. And there is a procedure how you calculate the wind pressure and all that, and then how we apply the wind pressure on the surfaces. And wind force due to gust effect needs to be sporadic gusts are there during the heavy winds, and the gust effect also is accounted for. And when we account for wind and seismic loading, the code permits us some increase in the allowable stresses because these are not daily. I mean, wind is a normal occurrence. Seismic loading is a once in a lifetime occurrence practically, at least in India right now, and a severe seismic condition kind of a thing. Now, seismic loading, the proposed building will be designed in accordance with code 1893. As per the code criteria, seismic loading zone 3, zone factor 0.16, importance factor 1.5, response. This is again with respect to the type of detailing, that is ductile detailing, performance factor, and the seismic base shear. SA by G, I mean, these are all parameters as part of the seismic loading. And how we calculate this, VB is called the base shear. Now, here, what you need to understand is the seismic weight of the structure which affects the base shear. And that is where to reduce the seismic weight, if we reduce the overall dead weight of the building, the base shear would be less. If the base shear is less, your impact of seismic loading on the building could be minimized. So you can just, as architects, you can just relate to that part of it for the time being. Of course, how to resist the seismic loading by way of adopting different structural system, we will talk in the subsequent session. So W is the seismic weight of the building, and which will be calculated in accordance with the relevant clause of the code. Soil loads on retaining walls, so will be considered in line with geotechnical report. That is where the geotechnical consultants' presence at the initial stage becomes critical, because it helps us understand the geotechnical parameters, account for soil loads in line with the property of soil, if it is clay, whether it is clay, whether it is sandy, whether it is sandy, silty, clay and silt mix, or it is murum, whether it is rock. Depending on that, these parameters which affect the earth pressure calculation can be verified and guided by the geotech consultant. And realistic loading can be accounted for, and correct loading can be accounted for. So proposed approach to structure analysis. The building will be predominantly planned with a structural system involving RCC slabs, beams, columns, and shear walls having moment resistant frames as the RCC frame structure. After preliminary sizing of various structural members, a computer model of the structural frame of the building will be generated for carrying out computer analysis for the effects of vertical and lateral load that are likely to be imposed on the structure. So we gathered the loading, now we are going to apply the loading on a 3D model. The building structure will be analyzed using the ETABS non-linear software, it's a software ETABS, which is thoroughly tested, validated, and internationally, and used normally for RCC structures. The analysis problem will be modeled using geometrical dimensions, member properties, and member node connectivity. The relevant eccentricities in the member connectivity. If a beam is sitting on one edge of the shear wall, then it will be modeled accordingly. That is what it means. Will be modeled in the analysis problem to the best possible extent, keeping in mind the limitations of the software, variation in material grades. If concrete of different grades are used, if you have a high rise, you may start with M80, M100 at lower floors, to keep the column sizes in check. If you are dealing with a 50 or 80-story building, you may need a higher grade of concrete to control the column size and give you minimum obstructions at the lower level. And that is what it means by modeling with certain different elements would be modeled with relevant concrete specifications and the concrete grades in the model. Wind load derivations will be carried out using the coefficient factors in accordance with the relevant code, which we saw just above in the previous paras. Seismic load are similarly would be worked out, and then for the dynamic analysis of the structure as per the code provisions. The permissible value of load factors and stresses will be utilized within the purview of the above mentioned standard. So now analysis method adopted for ETABS model. So how we process the model. So floor geometry shall be developed for buildings as per final general arrangement drawings, which we have coordinated with the architects, services consultants. We have arrived at preliminary member sizes at preliminary design stage. And vertical members will be connected from floor to assemble and complete the space frame. Preliminary sectional properties will be assigned to all the structural elements. Eccentricities will be introduced, connection eccentricities. All column shear walls will be treated as fixed at the foundation level. If you model it as a hinge, the structure may just overturn. The structure has to be fixed at the base so that you get fixed end movements at the base, and the way I showed you in the under wind loading, it behaves as a cantilever beam. The building behaves as a cantilever beam above the ground. The floor slabs will be modeled, introduced as horizontal diaphragm using appropriate methods. Basically, what this does is distributes the horizontal load equally, or rather in a proportionately rather to every column, so that the deflections between the columns, the relative deflections between the columns are within the permissible range and the floor does not tear off. And so the horizontal diaphragm performs that function that it binds the whole floor plate and a vertical element and makes them behave as a unit. So the floor behaves as a unit, and so the slab behaves, takes care of that as a diaphragm. Appropriate torsion or moment releases will be given wherever required. Appropriate grades of concrete will be assigned. Gravity loads, dead load, live load will be applied to all the respective areas as per the location, which you saw in the layouts that I showed you for loading in ETABS. Wind analysis will be done. Earthquake analysis will be done. Computer analysis will evaluate. The computer analysis will evaluate individual internal member forces, reaction at foundation level, and deflection pattern of the entire structure. So you can check deflections of individual beams, you can check deflections of slabs, you can check deflections of slab deflections. You may not be able to directly check in ETABS because it will have to be the model for the flow plate will have to be exported to another software from SAFE, but there is a compatibility between the two softwares, and it can be studied, in SAFE, the actual deflection if you want to study. But if your slabs are designed correctly, you may not really worry about the slab deflections. And beam deflections you can verify, and the floor deflections you can verify. Now, this data generated using this analysis model will then be used to verify adequacy of the member sizes adopted, and after further iterations, you arrive at the most appropriate reinforcement design of the structural members. Some reruns of the analysis program will be required for arriving at the optimum structural space frame characteristics that satisfy the strength and stability criteria in all respects. The architects and services consultant will be duly informed of any schematic changes required to be carried out for making the structural system fully compatible with the wind earthquake codes so that they can accommodate the changes in the overall planning of the building. So if we have any problems, compatibility issues, uh, beam depths are affecting the floor to floor height, not permissible. So there is a give and take relationship, whether we can increase some column size, reduce the beam span, introduce an additional column, whatever. So typically, these problems with experience, you do not get into these issues because your scheme proposed typically has already inbuilt properties or of bringing about an optimum solution in the initial runs itself, and that is where the experience comes to your rescue and saves you time in delivering a project. But uh, but yes, there are areas where for everyone it is a tight scenario, and it's like what to optimize when it comes to that. So that is where this becomes an interesting, design dialogue to resolve the issue because we are all problem solvers. We need to solve the problem. The space frame analysis will be carried out for gravity loads, wind loads, seismic loads, and all combination thereof. So these are different combination loads for which, here right now you can see 37 load combination for which the building is analyzed. Each and every element of the building has to be verified to satisfy to cater to the stresses caused by the different loading. So if your bending moment diagram for dead load, live load, and bending moment diagram for let's say combination 2 and combination 12 would be very different. So EQX is earthquake, EQY is earthquake, uh, DL is dead load, LL is live load, and similarly the earthquake will get replaced by wind load. So as you can see here, suffixes X and Y in the above table indicate the direction in which the force is applied. Wind combinations considering WLX and WLY would be applied in the same line as done for EQX and EQY. So practically from 2 to 37, that is 36 additional load cases would be modeled for wind. So you model 37 plus 36. So practically you are modeling 70, 70, 73 load cases and analyzing and verifying members for all under each loading condition and satisfying the design requirement. So that is the level at which it is designed and detailed, and hence you will realize that any later date change can upset the deliverables or upset the project schedule. And that's where this dialogue in terms of what to account for in the loading becomes so important for everyone involved to understand. And that's where the dialogue at the design various stage becomes extremely critical, or the concept stage and the design development stage becomes extremely critical. And that's where my initial slide, which spoke about an integrated approach to design, comes into play, and that is what I want to emphasize about. And then the structural design of different elements are carried out by relevant methods. Procedures are adopted, what software and how we will design different raft slab design. So now I'll just talk about the raft slab design. The raft slab and retaining wall will be designed for uplift pressures, appropriate hydrostatic pressures considering maximum groundwater level at ground level. Stability of structure would be checked. There are parameters how do you check the stability, like sliding and overturning against buoyancy. Typically, high-rise structure would not have much issue against buoyancy. That is the hydrostatic uplift. Geotechnical data we have recorded over here. Groundwater table which affects the so if you have a basement and which goes down to let's say 7 meters, if you think about the 2005 July flooding that happened, the rains that happened in Bombay, 26th July 2005, and the whole city was flooded. That is the worst water levels that we had in the city. So if you have full up to the ground, your graph slab may undergo uplift pressures to that extent. So a 7 meter what -7 meter, if we go down to into the basement, and if I have a 7 meter water table to deal with, then my uplift is 7 ton per meter square, as against a floor load that you can imagine the live load on the residential floor is just 0.2 ton per meter square. Or 2 kilonewton per meter square, as against 70 kilonewton per meter square uplift. So the water pressure could be phenomenal to deal with, and there are different techniques how you deal with that in the basement raft. But it's a critical uh, design aspect to be looked into if you are dealing with deep basement. In on large scale projects, basements are inevitable, and you have to deal with it. Foundation recommendations which are recorded, and precaution against presence of chemicals. So we take precautions in terms of using what kind of cement or what grade of concrete, how much cover to provide for reinforcement and all that. Other data, specific requirements of floor and wall cutouts for services, sinking of floors in services, kitchen, toilet areas, external architectural features, and entrance canopies will be provided as required by architects and services consultants. The relevant information will be obtained from them in the form of drawings. Lift loads and lift machine room equipment and cutout layouts will be obtained from the lift manufacturers. An impact factor of 100% has been considered in the lift supporting structure. This is the broad outline of the DBR. There are a few more pointers which I've deleted over here because I
Hello, hello. Sir, your voice is breaking.
briefing. I will. Yeah, can you hear me? Hello.
No. Your voice is breaking actually.
Hello.
Hello. Yeah. Now it's clear.
Yeah. Was I clear till the end, or it was breaking?
Till the DBR end, it was clear. Now.
In DBR and it was clear, right?
Yeah.
Okay. Now can you see the last one?
Yeah. We can see the slide.
Yeah. So now this brings to the end the discussion on this loading session, and this is an interesting structure. I just love this building since childhood, and fascinated. I'm fascinated looking at this building, and we'll talk about the structural frame and the structural systems in the coming lecture. This is one more interesting structure which I had seen. When I had been to Bangalore in the recent times. So this was under construction. This is a lift slab technique, one of its kind which I had seen in Bangalore. So this brings to the end the today's session, and thank you everyone for being patient and listening to me on this session. Thank you so much. Thank you,
Thank you, sir. Thank you,
for
sir.
the opportunity. Thank you, Anuja. Thank you, Parikshit,
Yeah, thank
Vinit
you, sir.
sir, Gaurish sir, and the other team members or other panelists on this series. Thank you for joining for this session.
Thank you, Devang sir. Thank you, Devang.
Thank you, Devang.
Yeah.
It was an important lecture and then start of this structural systems, because unless and until you know the loading correctly, then only structural systems will come. So it is how detailed architects as well as the consultant has to think about it at initial level itself, so that when you're going in a process, it doesn't hamper at the later stages. And it's important to have, and you have given that very importantly practical approach towards this integration, because as you rightly said that it is a very to and fro process between the architect, consultants, and the client, the needs. So it cannot be completely linear process, but definitely uh, a simultaneous process which has to happen, and which also has to be aware by the students when they are going through this academia. So it was a great to see that start from here. I guess it's a vast subject. I guess the five lectures which you have planned also will be slightly less. But I guess it is more of an overview, and it is more of an awareness of sorts as an architecture student, and the kind of inquiry which will generate because of that, and the further dialogues which will come after this is an important aspect which I feel which has been started because of this knowledge series, and we wish to continue that here onwards. So thank you very much to be here, and how detailed that DBR which you have discussed about, and that too also it's a structural DBR. We have already started for a couple of years down the line about a DBR, design basis report, for our design projects, and so how that as is a tool to help the design processes for implementation purposes, that we are trying to put it across the minds of the students here. And I guess somehow we are able to reach that, and in the future we'll be able to see our students adhering to these DBR, creating a DBR for themselves, and trying to become a better professional, which is an integrated professional when they step into the industry. So thank you very much to be here and trying to open up the detailed discussion for the structural framing systems. Thank you, Devang.
Yeah, most welcome. My pleasure. And any questions here? Anybody has any questions?
Students, any questions, guys? Hello.
No, sir. I guess they are trying to imbibe lots of things. I guess once they may be seeing the presentation again, they will be having some questions. As what I said earlier, also they will come through the faculty. Now they will start asking various questions to the faculty, and they may forward it to you in a coming series. You may able to answer those.
Okay,
I, I,
Devang, I have one question for you.
yeah, sure.
One question is that you spoke about internal wall being a AAC block. I think bit information about non-structural walls and integration and completely avoiding the weight works. And if we think about going for a non-structural walls, how can we deal with it? Because when we talk about the high rises, we should try to reduce most of the wet works. But still, I know because of the conduiting and because of so many services passing through it, non-structural internal wall. Now we are all doing external wall, but internal wall, something you could highlight maybe in the next lecture, or if you can talk about it a
No,
bit.
I can talk
Yeah,
about it right now also.
yeah, yeah.
Basically, in high rises, the internal walls, yeah, internal partition walls, lightweight partition walls that you do, they, you know, as per a good practice, they do not advise you to connect them to the. They advise you to provide the top restraint, but they do not advise you to connect it to the upper level slab. So you rest by gravity on the lower floor, and at top you need to develop a detail where you can support it laterally against lateral stability. But they advise you to keep slight gap between that, and but you can still connect it if you want to. But the advisable detail is to keep a gap for the internal partition walls. And I think that is one of the key elements. Probably, I think Anuja, you want me to highlight. Correct me if I'm wrong.
Yeah, exactly. So I think from the construction point of view or from the detailing point of view, yes, we are not yet comfortable with these internal non-structural wall because of the typical gap and the typical detail what happens between the structural slab and these vertical walls. So um, how can that detail can be imbibed into our designs, because especially for the residential, this is what the biggest challenge which all of us we face. And AAC block to the great extent have reduced the weight issue, but then labor component going till that top level, and especially after COVID, when we are talking about the technology oriented approach towards our construction technology, how can we overcome these wet works? And that's where I just wanted all students to get oriented that these kind of details and this kind of technology needs to be become a very important part of our high rise design, where we can reduce this labor oriented job where the sand is expensive. How can we reduce and make it more and more modular? So the whole direction should be, as you pointed out nicely, the integrated approach and more modularity, which will make the life simpler for especially for the high rises.
Yeah, absolutely.
Yeah.
And what you highlighted in terms of this walls, let me talk about high-rise hotel structures. Like something
Yeah.
like Westin that we saw, something like ITC Grand Central, and all high-rise hotels specifically. They have underslung plumbing. They have all walls, including the bathroom walls. The WC walls are all like, I mean, I don't think they are all AAC blocks. They are lightweight walls, and they are all dry walls practically, and they have finishes which allow you to have wet surfaces. So they have finishes which will take care of uh, if the surfaces are getting wet, but the walls would not get damaged. And that is where the construction, what you are talking in terms of the construction technology, speed of construction, dry construction. So in all hotel projects, typically a high-rise hotel structures, and even not even high-rise, some low-rise structures also in hotels. This is now it has become a norm, and it is adopted practically all across India, if I'm not mistaken. In good,
Yeah.
all good big brands are going with this kind of construction.
Correct. So non-structural wall can be the dry wall also, and these dry wall can become very much part of toilet wall. And these kind of details are also available, and how to marry them or how to detail them with the structural members. I think there are various possibilities which are possible. So I just want to open that discussion. Maybe you can take it in the next session if you want to
I
just.
think the non-structural aspect, I think Vishwas is going to talk in more
Yeah.
details.
Okay. So Vishwas is going to
So,
look
I'll
into all
leave it
this.
for
Great,
Vishwas.
great,
But I mean, since we
great.
are on the subject, I'll just touch upon one point that
Yeah.
even though they are lightweight, I mean, this dry walls,
Mm.
but the acoustics are taken care of by introducing, the glass wool or rock wool,
Correct.
and you can still take care of the acoustics with lightweight walls or these partition walls.
Yeah.
I think I'll leave it there right now. I
Yeah.
think
Yeah, right.
let Vishwas
Great.
address it with more
Yeah.
detail in his
Uh,
lecture.
Parikshit, I hope this is not something which is very heavy for the students, and maybe they are
No,
oriented, or it's opening a new direction for them, because this is what we are doing in
yeah,
the practice and we are discussing.
right,
So,
right.
so
I
I
totally
feel that they should get at least oriented with the terminologies and what new
exactly.
technologies are coming
Uh,
up into the market.
that is that is one of the reasons. I mean, since I had taught the second year architecture students in the past,
Mhm.
and I've interacted with architecture students in the past. That is where I did not want to get too much into the theoretical aspects of the structural design and the code provisions, talking because I think the formulas and the detailed code provision and clauses would not make sense to me. I
No,
think
no,
it
it
is
will
more.
not. It will not. For architectural student, it's like newer technologies are very important, because high rise is all about that. And as I said, that modularity is something which is going to be very important for the high rises. And even from the
Right.
construction point of view, when you come up with 4 residential towers of the identical flow plate, and when you have to repeat the shuttering, or all such modular details are there, and when you are going all 50-60 storied 4 towers, then all these elements which works wonderfully well to the detailing also, and it wonderfully works even from the cost perspective and the speed of the construction. And architect needs to understand and imbibe all these into them. They have to understand, so that's a core knowledge, and they shouldn't isolate themselves from understanding these new technologies. That's what I feel.
Yeah, absolutely
Yeah,
right.
yeah,
It's important to get aware and start
yes,
integrating, understanding these kind
correct,
of various aspects of
yeah,
the material, because many times what we have been doing in architecture academic platforms are more or less we are inclined only towards the aesthetic parts of it, but there are various other aspects which has to be considered for various other reasons for that matter to make the project viable and buildable and still appear to be a better outlook. So I guess that is very important to get aware, and that is why we have to be updated with the technology, materials palette which has been available day by day, because lots of things which comes out and we are still at least 10 to 15 years back when we start using the materials, because that updation of materials are very important aspect which we have many times get ignored, and then other people who are able to innovate and integrate that with their design, they go on and then start bagging the project. So it's important that awareness has to be there at the college level itself, so that they know the approach how they have to go after it.
Yeah, Veritas slightly differ. I feel that today's students are much smarter, and they have good information tools available with them, and that's what my experience being in professional, being teaching them. Yes, they are very much aware, and I must mention that they had really asked good questions in the past. So I'm very sure I'm just trying to give them that direction, that they have to get into all that, and that's where. The whole future is for them, and it's very interesting. So I really want to create, I really feel that they should get inspired with all this. So I think they are very smart, very talented, and I'm very sure they are going across the globe and seeing all wonderful architecture and technologies which is coming up.
Yeah,
Absolutely.
I
So
think
great session, Devang.
yeah.
Thank you.
Yeah.
Devang sir, I just have to, I mean, I would like to add one more thing. So maybe
Yeah.
in next lecture, if you can add those logistical requirement provisions in the structure for maybe fixing of crane, booms, and lifting cranes, and also what are the logistical.
Actually, I'm just intervening.
Yeah, yeah.
Parikshit, you can ask Yogesh to integrate those, because he's going to talk about the project management part
Yeah,
of
no,
it.
no, no, no. I'm talking
Okay,
about structural aspects. I mean,
okay,
structural
structural
provisions.
aspect
Yeah,
of, okay,
yeah.
yeah,
Structural aspects and structural provisions of those. Maybe in the next lecture, along with the structural system, uh,
okay.
we can.
No, actually, those are, what you are talking are the provisions. Those provisions would bring about how you connect them. These are all temporary structures, during the construction stage,
Right.
and how you connect them to the structure, and how you ensure their stability, and what kind of forces they bring upon the elements where you connect them. But we will try and
Exactly.
connect, touch upon that point.
Sure,
But
sure, sure.
I think we will touch upon that. Not a
Yeah,
problem.
sure. Definitely. But this
I can see.
methodology,
Sorry,
this.
I can also see Sangeeta over here. She's
Yeah,
there. So,
yeah.
Sangeeta,
Sangeeta
thank you
ma'am.
for being there. And if I've missed out any point, kindly highlight. Since you are here, with
Yeah,
respect to the subject.
Sangeeta ma'am. Welcome, ma'am.
If she wants to highlight, she can highlight if I've skipped anything, because she would understand what I was talking.
Yeah, sure. But I think yeah, the great session, and student will come to know what is the professional methodology of the or approach of the project in terms of design and
Sure.
structural. Sure. Thank you, sir.
Thank you everyone for being
Yeah,
here. Thank
thank you. Thanks a lot, sir. Thank you everyone.
Thank you.
Thank you.